To begin the video or discussion, whatever you want to call it, on transistors and their uses, I think it's necessary to explain what diodes are and how they are used. I decided to do this in Minecraft because it was easy to demonstrate and because redstone can be used as a good alternative for demonstrating electricity. A diode is an electrical component that's used in a circuit to allow electricity to flow in only one direction. They are made by having a p-type semiconductor and an n-type semiconductor pressed directly together with wires on opposite sides. In this instance, pretend the repeater is a diode. When I switch the direction of the repeater, or the diode, whatever you want to call it, is facing, it restricts or allows current to flow. The P and N-type materials mentioned earlier are created by taking a semiconductive material like silicon and doping it with impurities. No, I don't know why it's called doping. It sounds like drugging. Or, yeah, you know what I mean. Depending on the element chosen to make the impurity, like arsenic or boron, the silicon will have a surplus or dearth of electrons, making it have an affinity towards being positive or negatively charged. After combining the P and N-type materials, some electrons transfer, creating an area that has no free charges and its own electric field. This area is called the depletion layer, and because it's electrically neutral, it resists current flow. When a power source is connected to the diode, like a battery, another electric field is created, the power from the wire, and depending on the direction this other electric field points, the depletion layer increases or decreases in size. When the layer decreases in size, it's recognized as a forward bias, and when it increases in size, it's recognized as a reverse bias. A forward bias allows current flow, while a reverse bias does the opposite. This is how it stops or allows electricity to flow through it. Because the topic was so similar, I'm including information about solar cells. In simple terms, a solar cell is just a different type of diode with a completely different purpose. Instead of impeding current flow, it converts light energy into electricity. When the photons from light hit the depletion layer, the bonds between electrons and holes, or areas that don't have electrons, break apart, migrating the electrons, creating electricity. This quick explanation is really simplified, and I encourage you to go and look at whoever is doing that topic. I do think it's Adriana, that's what the thing says. Now that diodes have been explained, I can finally go on to transistors. Transistors are basically just diodes, but with an added P or N layer, making them PNP or NPN, with that P-type, N-type, P-type, or swap it. After that, an additional wire is attached to the middle layer called the base wire, and you now have an electrical junction that can go either way. Transistors are probably one of the single most useful pieces of circuitry because of how much they can do. Depending on the current they are exposed to, they can give a plus or minus response, which for many means yes or no, but for computers this is most commonly recognized as ones or zeros, or binary. With the integration of transistors into a circuit, it is even possible to create logic circuits. A logic circuit is a system that gives a response depending on factors given. Common logic circuits include, but are not limited to, AND gates, which is this and this equals yes, OR gates, which is this or this equals yes, but this also includes AND for some reason. XOR gates, which is actually OR, so either OR equals yes, but not both of them. NOT gates, this just inverts so yeses become no's and no's become yeses. NAND gates, which is a inverted AND gate, typically just a NOT gate and an AND gate combined for inversions. NOR gate, which is an inverted OR gate, and a XNOR gate, which is an inverted XOR gate, which is the either or one. All of these different gates are used in conjunction to make CPUs of computers, and the more transistors that companies can put on the CPU wafer, the higher the power, or in more appropriate terms, the faster it can process data. Companies like Intel and AMD are constantly trying to find ways to put more transistors onto their CPUs, so they are constantly lowering the nanometers in between each transistor to try and get more power for more efficiency, to try and lower prices to get more money. Something else. If you can create all these logic gates in Minecraft, what's to stop you from creating a full-blown computer in Minecraft? The answer is nothing beyond having time to do it, and I'm going to include footage of me going around a giant computer. The problems real computer engineers face are actually the same ones Minecraft ones do too, which is the distance between transistors. So they have a hard time including very many transistors because Minecraft you can't lower the distance. It's you're just stuck. Whereas real life they're constantly trying to minimize those gaps. After looking at the rubric, I've realized that I need to connect this topic to something we've done in classes here. This explanation of transistors tells you how almost all of our scientific devices work, and without transistors you wouldn't have been able to attend class for the last 3 months. So, if that doesn't show how relevant the technology is, I don't know what will. Also, fun fact, transistors require a current to stay switched to be functioning. So a lot of old devices weren't able to store memory, or it was really expensive to do so without things like punch cards or a literal physical thing or magnetic storage. So really old video games, if you wanted to save the game, you'd be required to have a battery inside which would slightly recharge every time the cartridge was plugged in. Yeah, people don't care. Yeah, this is the end of the video.